Welcome to Electromagnetics lecture series. I, Professor Hitesh Dolakia, is going to explain you examples on electric field due to line charge density. So let us have first problem here. So I am writing it. So here uniform line charge distribution rho L is equals to 20 nanocoulomb per meter, that is given to us, and that is there on line x is equals to 2 and y is equals to minus 4, and we are dealing to determine electric field at minus 2 comma 1 minus 1 comma 4 meter coordinate. So here first of all we need to understand geometry. So step by step you see how to understand geometry, right? So let me draw first of all coordinates here.
So see, this is z coordinate, this is y coordinate, and this is x coordinate, right? And as per extension, I think it should be clear to you like what are the coordinates, right?
Now see what is line x is equals to 2. So x is equals to 2, if I say that is over here, right? X is equals to 2 and y is equals to minus 4. So y is equals to minus 4, that will be somewhere over here. So if you see the connection of this 2 point, then that is over here. So ultimately line that is happening over here like this. So first of all we need to understand what is this line, right? And on this line line charge distribution rho L is equals to 20 nanocoulomb per meter. So first of all you need to understand how this line is there. As per the data which is given to us, x is equals to 2 and y is equals to minus 4, line is there. So it means over here like this line is there. So line is there with respect to z axis, right? And now see point is what? Minus 2 comma minus 1 comma 4. So if I say this point is somewhere over here, minus 2 comma minus 1 comma 4. So obviously electric field, because of this line charge density, that will be in this direction. But what will be this perpendicular distance? So for this perpendicular distance we need to know what is this point. So this point, see this point, that should be having see same coordinate as z coordinate. So z coordinate of this line, as this is z axis, so minimum perpendicular distance that is having same z coordinate as z is varying, right? X and y is same, but z is varying. So z coordinate is same as this point. So when you write coordinate of this point, so that will be having same z coordinate. X and y coordinate that we know, x is 2 and y is minus 4. So x is 2 and y is minus 4. So this point coordinate is this. Now based on this 2 point, we can say what is the direction of this electric field, right? So ultimately, see this is the basic distance, and this is the direction, and basic formula of electric field, that is rho L divided by 2 pi epsilon 0 r into unit vector r direction. So unit vector r, that is vector r divided by mode of r. So this formula will get changes to rho L divided by 2 pi epsilon 0 r square into vector r direction. So now we need to calculate what is vector r and magnitude of r. Rho L is there with us. So see vector r, that is in this direction, means this point minus this point, right? So vector r, that is minus 2 comma minus 1 comma 4 minus this point, so that is 2 comma minus 4 comma 4. So if you do this, minus 2 minus 2, so that is minus 4, minus 1 minus minus 4, so minus minus plus, so minus 1 plus 4, so that is plus 3, and 4 minus 4, that is 0. So vector r is this, and magnitude of r, that is square root of 4 square plus 3 square. So 16 plus 9, 25 square root, that will be 5. So r is 5. Now we can place these values in this, so we can have electric field. So now electric field will be rho L, that is 20 nano coulomb. Nano means 10 to the power minus 9, divided by, now you see 1 by 4 pi epsilon 0, that is 1 by 4 pi epsilon 0, that is 9 into 10 to the power 9, right? So 1 by 2 pi epsilon 0, that should be 18 into 10 to the power 9. So 1 by 2 pi epsilon 0, that is 18 into 10 to the power 9, as 1 by 4 pi epsilon 0 is 9 into 10 to the power 9. So 18 into 10 to the power 9 and divided by r square. So this is 25, and in the direction of minus 4, 3, 0. So see, 10 to the power 9 will get cancelled, and this is 20 into 18 divided by 25. So 20 into 18 divided by 25. So this is 14.4. Let me write this first. 14.4 into minus 4, 3, 0 direction. So exactly 14.4 into minus 4. So that is minus 57.6. And 14.4 into 3, so that is 43.2, 0. Electric field is Newton per Coulomb. See, this is how we can calculate electric field. So this is what the basic thing which we need to focus when we calculate electric field due to line charge. Let us have one more problem, so it will be bit easier. So let me write problem first. So here, uniform line charge of 120 nanocoulomb per meter lies on entire x-axis, and we are dealing with to find electric field at point minus 3, 2, minus 1 meter. So let me draw the situation first. See, this is z-axis, this is y-axis, and this is x-axis, right? And here uniform line charge that is there along x-axis, right? So see, this is line charge, uniform line charge that is there along x-axis, and that line charge, that is rho L, and that is equals to 120 nanocoulomb per meter. And our question is find electric field at this point minus 3, 2, minus 1. Let us say this point is over here, minus 3, 2, minus 1. So obviously electric field direction over here, that will be in this direction. So first of all, this is what the perpendicular distance that we are talking about, minimum perpendicular distance, right? And first we need to find this point. So what is this point? Now see, on this x-axis, y and z coordinate, that will be 0, right? And x coordinate y and z coordinate will be 0, and x coordinate, that is same as this coordinate, right? So x coordinate, that is minus 3, and on x-axis y and z coordinate is 0. See, this is how we need to find this point, right? So this point, that is minus 3, 0, 0, and this direction, that is this point minus this point, right? So this electric field, first of all I need to write this over here. Electric field, that is rho L divided by 2 pi epsilon 0 r into unit vector r. Rho L divided by 2 pi epsilon 0 r, unit vector r is vector r divided by magnitude of r. So this will change this formula to rho L divided by 2 pi epsilon 0 r square into vector r. And here this vector r, see, that is in this direction, means this point minus this point. So this will be minus 3 comma 2 comma minus 1 minus minus 3 comma 0 comma 0. So this will make minus 3 minus minus 3. So that is 0 comma 2 comma minus 1. And magnitude, so that is square root of 0 square plus 2 square plus minus 1 square. So this will be square root of 5. Now place all those points and values in this formula. So if you place these values, so electric field, that is, now you see 1 by 2 pi epsilon 0. So 1 by 4 pi epsilon 0, that is 9 into 10 to the power 9. So 1 by 2 pi epsilon 0, that is 18 into 10 to the power 9. Into rho L, that is 120 nanocoulomb. So 120 into 10 to the power minus 9 divided by r square, so that is 5 root 5 square, that is 5 into point 0 comma 2 comma minus 1 direction, 0 comma 2 comma minus 1 direction. Now you see this will get cancelled. 120 into 18 divided by 5. So 120 divided by 5, that is 24. 24 into 18. So that is 24 into 18. That is 432. So I can say this is 432 into 0 comma 2 comma minus 1 direction. So I'm just saying, see, 40 comma 432 into 2. So that is 864 comma minus 432 volt per meter. See, this is what electric field as per this line charge. Now I think it is clear to all like how to calculate example based on electric field due to line charge, right? So if any situation has been given to you, you first of all try to understand how that is placed and then calculate. See, understanding is required. It is not about formulas. Here, for nothing to do with formulas. Formulas are very simple. Only thing is we need to understand direction and calculation. So I hope you will be practicing as per the explanation which I am giving it over here, and definitely this practice that will help you to sort out all those queries which is happening regarding electric field calculation. And you just give your valuable suggestions. Your suggestions are most welcome.